Hi, good day. Our topic for this video is about mesh analysis. There are circuits that are simple and can easily be solved using Ohm's law. Okay, so Ohm's law being applied to a simple series, simple parallel, or simple series parallel circuits. However, there are some problems or there are some circuits that are difficult to solve using the simple series and parallel combinations. So therefore, from our previous videos, we have discussed the Kirchhoff's laws. Okay, so those type of circuits, Kirchhoff's laws, both the KVL and the KCL can help us to analyze certain types of circuit problems. Okay, however, there are more complicated or complex circuits, particularly those with many components. Okay, so many components means many unknowns. Okay, so many unknowns means we have several terms to analyze or to solve. Therefore, that also means we have different equations to solve simultaneously. Okay, so there are different methods available to help us with these types of circuits, and mesh analysis is one of them. Okay, so mesh analysis is a systematic method of analyzing circuits. Okay, so I have mentioned Kirchhoff's laws a while ago. So mesh analysis is somewhat related or based on the Kirchhoff's voltage law. Okay, so it gives us what we call the mesh currents in the circuit. So when we use mesh analysis, that means we are solving the mesh currents in our circuit. So once we have this mesh currents, therefore we can already find any other current or voltages in our specific circuit. So let us recall from our previous definitions that in a certain or in KVL, we are usually traveling across a loop. Okay, so what do we mean by a loop? So loop is any closed path in a circuit. Then we also have a definition wherein mesh, okay, so it is a sort of a loop. However, mesh is a loop that doesn't contain any other loop within it. So let us now differentiate loop from mesh. Okay, so here we have here 6 different loops. Okay, so where are our 6 different loops? So we have this first loop. This is our first loop. Okay, so loop number 1. We have here our loop number 2. We have here our loop number 3. Okay, so we have here our loop number 4. We have here our loop number 5. Okay, and then we have our loop number 6 at the outer part. Okay, so we have here 6 different loops. Okay, however, when we say mesh, we only have, okay, so we only have 3 meshes here because a mesh is a loop that doesn't contain any other loop within it. So we have here our mesh number 1. Okay, so the yellow arrow here. So we have here our mesh number 2, and then we have here our mesh number 3. So in this particular type of circuit, we have 6 loops and we have 3 meshes. Okay, so let's continue. As I've mentioned a while ago, so in mesh analysis, we are actually solving, or we are actually analyzing for the mesh current. So when we say a mesh current, it is a current that we imagine to travel around a mesh. Okay, so you can imagine them to travel in either direction. It can either be in a counterclockwise or it can also be in a clockwise direction. Although, okay, most of the time we are assuming a clockwise direction for mesh currents. Okay, so what is the difference between a mesh current and a branch current? So usually when we use the Kirchhoff's laws, okay, we are trying to solve for the branch currents. So the branch current is a current that passes through a branch or an element. Okay, so for example, there are 5 branches in your circuit, so therefore there are 5 branch currents that we are asked to solve for. So 5 unknown currents means 5 different equations for us to solve for those 5 different unknowns. Okay, but if we are going to solve for mesh currents instead of the branch currents, all we have to solve are the mesh currents, and when we have already solved for the mesh currents, then we can compute for your branch currents. Okay, so mesh analysis gives us a lesser number of unknown currents, therefore a lesser number of simultaneous equations that we can or we have to solve. Okay, so usually we denote small letters, okay, for mesh current. So for mesh current, we make use of small letters, like for example, I1 or I2 or I3. Okay, however, for branch currents, we usually make use of capital letters. So like, let's take for example, I1, I2, and I3. So we make use of the small letters, although this is just a to differentiate the two. But if we're just dealing with mesh currents, it's okay. So this is just for you not to be confused whether you're solving for the mesh currents or the branch currents. Okay, so we have here in this circuit, for example, so you can see currents, okay, that have small letters. So those are denoted by the mesh currents, and then those capital letters are denoted or are used for branch currents. Okay, so in this circuit, the mesh currents are labeled I1 and I2. So how many mesh currents do you have in a certain circuit? So usually the number of mesh, okay, the number of mesh in a circuit tells you how many currents or how many mesh currents you are required to solve. Okay, so in this circuit, for example, we have 2 meshes. So where are your 2 meshes here? So this is your mesh 1, okay, this is your mesh 1, and this is our mesh 2. So we make use of a clockwise direction, okay? And they are labeled as I1 and I2. Notice the small letters here, okay? So the branch currents are those currents that is flowing on a certain branches. Okay, so for example, we have here your I1, we have here your I2, we have here your I3. Okay, at the same time, okay, so if you're asking why no current here at I4, because your I2 is the same current that will flow across your I4, across your 4 ohm resistor here, making this 6 and 4 in series. Okay, so therefore we have here 3 branch currents. So if we're going to make use of Kirchhoff's laws, okay, we need 3 equations because we have 3 unknowns. So where are your 3 unknowns? So your I1, okay, your I2, and your I3, okay? So, however, when we're going to make use of mesh analysis, we only have 2 mesh currents. Therefore, we only need 2 equations to solve for these 2 mesh currents. Now, if we already know, okay, so suppose you are already given the values of the mesh currents of this I1 and this I2 here, we can easily solve for the branch currents. Okay, like for example, as you can see, your I1 here is the same current that will flow across your 5 ohm resistor here, making your I1 here, your branch current I1 equal to your mesh current I1 here, okay? So at the same time, okay, so your I2 here or your mesh current here is the same current that will flow across your 6 ohms and your 4 ohms resistor here, making your I2 or your branch current 2 equal to our mesh current 2, okay? However, at I3, okay, or at branch I3 or at the 10 ohm branch, we can see that your I3 is somewhat a combination of your mesh currents 1 and 2. Okay, so how are we going to solve for I2 now? So we will combine them and look at the direction. Whichever is following the proper direction of your branch current I3, so we will be treating that as positive, and the other one which opposes the direction, so we will be treating that as negative. Okay, so if we're going to follow this loop here, we can say that your I1 is in this manner and your I2 is in this manner. So if this is our assumed value of I3, I1 has the same direction as your I3 here, okay? While I2 here has the opposite direction of our I3, making your I3 here equal to I1 minus I2. So which is easier? It is easier to solve two unknowns using two equations than solving three unknowns using three equations. So this type of circuit can be solved using your Kirchhoff's laws, okay? However, we will be needing three different equations. So maybe a combination of KVL and your KCL. But if you're going to make use of mesh analysis, this circuit here is, or you can solve this circuit by just using two equations. Therefore, you will just solve for your mesh current 1 and mesh current 2. Okay, so what are the steps, okay? What are the steps in performing mesh analysis? So we have different cases, okay? So this first case, for example, is performing mesh analysis with no current source. Okay, so how are we going to solve for the mesh analysis with no current source? So given a circuit with n meshes without current sources, we just have to follow these steps. Okay, so here are the following steps. Okay, so first, assign mesh currents I1, I2, or depending on how many meshes do you have, that is also the number of mesh currents that you will that we are trying to solve. Okay, so to the n meshes. Okay, and then we're going to apply KVL to each of the n meshes. Okay, so we're going to use Ohm's law to express the voltages in terms of your mesh currents. Then simplify the equations. So we have to solve for the resulting n simultaneous equations to obtain the unknown mesh current. So later I will be explaining how are we going to write the equations. So here the trick is the equations that we're going to write. But once you're already familiar on how to write mesh equations, this is very, very easy. Okay, so this approach is very, very easy. So what if we have a current source located in only one mesh? Okay, so in this case, for example, we have a current source, and that current source is directly located at mesh number 2. So in this case, a current source located in only one mesh is easy to handle, okay, because it immediately reveals the mesh current in that specific mesh. For example, this one, as you can see, we have here 5 amperes, okay? And that 5 ampere here is located at mesh number 2. So therefore, mesh number, we do not have to solve for mesh current number 2 anymore, because it is already given in our current source here. So the only thing that you will have to see or to find out is whether they have the same direction. So like for this example, your I2 is flowing in this manner, which is opposite to the direction of your current source. Therefore, in this circuit, we can immediately say that your I2 here is equal to -5. Okay, so your I2 here is equal to -5. So why -5? Because of their direction. What if they have the same direction? For example, if your I2 is also flowing in this manner, or let us say your current source is also flowing in this manner, just like our mesh current number 2. So therefore, I2 is equal to +5. So it becomes negative here because the mesh current number 2 flows in the opposite direction as our current source. Okay? And then, so the first case is when we do not have a current source. Okay? So later I will be showing you how to create the equations if we don't have any current source. Now, the second case is what if we have a current source which is flowing or which is located at a single mesh. So the mesh current in that specific mesh is already equal to the current source that is connected in that certain specific mesh. So the third case is a current source shared by two meshes. Okay, so in this case, you can see that we have two meshes. So this is our mesh number 1. Okay, so this is our mesh number 1 and this is our mesh number 2. And between mesh number 1 and 2, we have here a current source. Okay, so a current source shared by two meshes is trickier. Okay, although it will be easier in our equation, but we have to look at this more closely. Okay, so if we don't have a current source between these two meshes here, we have two equations, okay, wherein we have your first mesh equation and then you have your second mesh equation. Okay, so how are we going to handle this type of problem? So in this type of problem, we have created what we call a super mesh. Okay, so what do we mean by a super mesh? Super mesh is created whenever there is a current source between two meshes. Okay, so how are we going to handle super mesh? So to handle this, we create a super mesh by excluding the current source and any elements in series with it. Okay, so as you can see, we have removed the entire branch containing the current source. Okay, so if we don't have a super mesh, we can treat this circuit with two mesh equations. Okay, but if we have a super mesh, we can treat this as a single KVL. So if no super mesh, we have two KVLs here. If we have a super mesh, this is considered, or this contains one KVL and one KCL. Okay, so what is your KCL? KCL is the current. Okay, so the current which will flow across this specific node. Okay, so what is our KCL equation for this? So as you can see, we have here your 6 amperes, okay, and your 6 amperes is equal to what? Okay, so which current between I1 and I2, between mesh current 1 and 2, has the same direction with your current source. So as you can see, I2, okay, I2 here has the same direction while I1 has the opposite direction. So therefore, the KVL equation that we can form here is equivalent to 6 ampere is equal to I2 minus I1. So I2 is positive because it has the same direction as the current source, while I1 is negative because it has the opposite direction as of the current source. Okay, so this is our first equation. So the first equation is a KCL. So we can only have a KCL if we have a super mesh. Otherwise, we have KVL. We are using KVL. So the only time that you can have a KCL equation here is when you have a super mesh. So most of the time, we use KVL. Now, how are we going to get our second equation? So our second equation is Kirchhoff's voltage law. So what you're going to do is you're going to remove the branch that contains the current source. Okay, so in this case, we are going to remove not only the current source 6 amperes, but the entire branch, meaning the 2 ohms is included. So here now is the resulting circuit. And then we use your KVL. So what is our KVL here? So that will give us, 20. So this is your first equation, and this is our second equation. So this is our second equation, which is your KVL. So the first equation is KCL, and our second equation is KVL. So we just have to follow the loop. So our loop here is, look at our loop. So it will go out at positive 20. So we have here 20, okay, which is equivalent to what resistors or what resistor wherein I1 is flowing. So that is 6. So we have here 6 I1. Okay, or sorry, so 6 I1, okay, plus, okay, so we have here 10 plus 4, okay, and the current flowing across 10 and 4 is your I2 multiplied by I2. So we have two unknowns, I1 and I2. Okay, so we have two unknowns, I1 and I2. So therefore, we can solve them using two simultaneous equations. And we have here your first equation and your second equation here. Okay, so again, I'll repeat. We only have KCL, okay, once we have a super mesh. So if we don't have a super mesh, all of the equations that we're going to write are in a form of KVL. Okay, so we have here we have some reminders, okay, before I show you how to create mesh equations. Okay, so you have to remember the directions of mesh currents can be selected arbitrarily. Okay, so if we assume each mesh, okay, so the equations that I will be showing you are assuming that we are using the clockwise direction. Okay, so if we assume each mesh currents to flow in the clockwise direction, therefore put this in your mind. So remember this, okay, all resistances, all self-resistances. So what do we mean by self-resistances? When we are talking about mesh number 1, so therefore, all of the resistances that were in I1 is flowing, or mesh number 1 current is flowing, we always treat them as positive. Okay, however, all mutual resistances, so what do we mean by mutual resistances? Those resistances being shared by two different mesh currents, okay, we are always going to, we will always be treated as negative, okay? So self-resistances, treat them as positive, and mutual resistances, resistors being shared by two different mesh currents, will always be negative, okay? So how are we going to write those mesh equations, okay? So the only trick here is you have to write the mesh equations, because once you have already written the mesh equations, so you can now solve your simultaneous equations, okay? So depending on what approach is easier for you, okay? So there are different ways in solving simultaneous equations. So the important part here is we have to write the equations, because of if your equations are wrong, therefore, even though you are good in solving simultaneous problems, but if you have wrong equations, therefore, you will not get the correct answers. So the important part here really is to solve or to write the proper mesh equations. Okay, so once your mesh equations are correct, that will guarantee you a higher chance of getting the correct answers, because you have to do your math pa. Okay, pero here, what I'm going to teach you is to write your mesh equations. Okay, so here is our first example. Okay, so here is our first example. We have here 3 meshes. Okay, so I will be calling those meshes. So we assume a clockwise direction. Okay, so you have here your I1. This is your mesh number 1. We have here your I2. This is your mesh number 2. And we have here your I3, which is mesh number 3. Okay, so therefore, we are trying to solve for 3 different mesh currents. So if we are trying to solve for branch currents, there are 4 branch resistors here. So we have 1, 2, 3, and 4. So that means we need 4 equations. So 3 equations are easier to solve simultaneously compared with 4 equations. Therefore, in this type of problems, it is easier to, this type of circuit is easier to analyze using the mesh analysis. And one thing more, okay, so this is quite easy again because we have a current source. Okay, so the 3 amperes, we have a current source that is located only in one of the 3 meshes, making our I3 already possible. Okay, so we have already a value for our I3 because of this current source here. Okay, so what are our 3 equations? Okay, so for mesh number 1, okay, so for mesh number 1, that means we are solving for I1. So let us look first at the source. Okay, so if we follow this clockwise rotation here, we will be going out at positive 10 volts. So all we have to do is to write here your 10 volts. Okay, so that is equal to, okay, so from the previous slides, all self-resistances, okay, will be treated as positive. So what do we mean by all self-resistances? All of the resistances wherein I1 or mesh current I1 is flowing. Okay, so what are those resistances? So those are 1 ohm and your 3 ohms. Okay, so we will treat that as positive. So we have here I1. Okay, and as we mentioned a while ago, all mutual resistances. So what does mutual resistance means? Those that are being shared by 2 mesh currents will be treated as negative. So how, like here, for example, 3 ohms here, okay, is a mutual resistance between I1 and I2. Okay, so it is a mutual resistance between I1 and I2. Therefore, we will treat your I3 or your 3 ohms here as negative. So that means 3 I2. Okay, so self-resistances are positive. So we have here 1 plus 3 multiplied by I1 because we are at mesh number 1. And then all mutual resistances. So therefore, 3 here, we will treat that as negative because aside from I1, mesh current I2 also flows across your 3 ohms resistor here. Okay, and then finally, if you're going to look at this I1 here, this is also a mutual resistance because both I1 and I3 can flow across your I1. So we will also treat that as negative. So that will be minus, okay, I3. So this is our first equation. Or we can simplify that as 10 is equal to 4I1 minus 3I2 minus I3. So that is our first equation. Okay? So where is our second equation? So therefore, we have 3 unknowns, I1, I2, I3. We need 3 equations. Okay? So where is our second equation? So we go to mesh number 2. Okay? So mesh number 2. So therefore, we are going to treat your I2 here as your self-resistance. Okay? So in this case, I2 is all those resistors connected to I2 will be treated as the self-resistance, and other resistances connected between I2 and other meshes will be treated as mutual resistances. So how are we going to solve for this? So if we're going to follow this mesh here, we don't have any voltage nor current sources. So therefore, for our constant, we will just have to write 0 here. Okay? And then, what are those resistances that are connected to I2? So all of those resistances connected to I2 will be treated as positive. So what are those? You have here 3, you have here 2, and you have here 4. So we have here I2. And all other mutual resistances will be treated as negative. So like, for example, we have minus 3I1 and we have minus 2I3. Okay, so rearranging the equation we have here 0 is equal to minus 3I1, okay, plus, you have 3 plus 2, 5 plus 4, you have 9, 9I2 minus 2I3. So we have here your second equation. So first equation from mesh number 1, second equation from mesh number 2. Okay? So we need one more equation and we will go to mesh number 3. Actually, mesh number 3 is the easiest because, okay, we find a current source that is directly connected at mesh number 3 and only mesh number 3. So whatever current your I3 is flowing here, that will be equivalent to your current source here. However, as you can see, your I3 is flowing in this manner while the current source is flowing at the opposite direction. Therefore, they will be sharing the same amplitude but only different in the direction. And the difference in the direction will be represented by a negative sign. So that means for mesh number 3, we don't need anymore to formulate the equations like what we did in mesh number 1 and mesh number 2. Because right away, we can say that your I3 or your I3 here is equal to negative 3 amperes. Okay, so we have already solved for the value of your I3. So using this 3 now, you can substitute that to the equation number 1 and number 2. So whatever type of solutions that you want, okay, so you already have your I3 here. Therefore, you can now solve for I1 and then your I2. Okay, so if you already know I1 and I2, therefore, you can already solve for the different branch current here. So for example, what is the current flowing across the 3 ohms resistor here? So whichever is higher, okay, so for example, this is your I2 and this is your I1, we can say that the current flowing here is equivalent to I1 minus I2. So why I1 minus I2? Because I1 shares the same direction as your branch current direction here compared to your I2 or whichever is higher between the two. Okay, so the same as the branch current across here at 2 ohms and the branch current across your I1. So no problem with the branch current at the 4 ohm resistor, because as you can see, only I2 is the one flowing across your 4 ohm resistor. Okay, so what is important here is you have established the mesh equations. So what are those mesh equations once again? So this is your mesh equation 1, this is your mesh equation number 2, and this is your mesh equation number 3. So once you have established your 3 mesh equations, because we have 3 meshes here, you may now solve for I1, I2, and I3 using using simultaneous equations, okay, which is easier for you. Okay, so what is important is you have those 3 mesh equations. So let's have another example. Okay, so in this case, we have 4 meshes. Okay, so we have I1, so we have I1, mesh number 1. We have your I2 as mesh number 2. We have your I3 as mesh number 3. And we have your I4 as mesh number 4. Okay, so therefore, we have 4 mesh currents. Then, we have to solve them using 4 mesh equations. So, how are we going to write your 4 mesh equations? Okay, so first, let us inspect the circuit. Okay, so as you can see, we don't see any current sources here in the circuit. So, all voltage sources. So, we will be making use of KVLs. Okay, so let us now go to mesh number 1. Okay, so mesh 1. So for mesh number 1, let us follow the clockwise rotation, and it goes out to positive 4. So that means we have here 4. Okay, so 4 volts. So that is equal to all connected to I1, all resistors connected to I1, we will treat them as positive. So what are those resistors? Resistances connected to I1. So those are your R1, your R7, and your R5. So we can write here 2 plus 4 plus 1 multiplied by I1. Okay, so all self-resistances will be treated as positive. However, there are also mutual resistances. So like for example, R7, because R7 is not only connected to I1 but also to I2. So therefore, we will treat that as negative. So minus 4 I2. Okay? Likewise, 1 ohm is also a mutual resistance. Why? Because it is not only connected to the mesh 1 but also to mesh number 3. So therefore, we will treat that as negative. So we have here minus 1 I3, or simply minus I3. So simplifying this further, we have 4 is equal to 4 plus 2, 6 plus 1, 7. So we have 7I1 minus 4I2 minus I3. Let us call that your equation number 1. Okay? So how about equation number 2? So where are we going to solve for equation number 2? We will go to mesh number 2. So let us write here mesh number 2. Okay, so we will be concentrating on the second mesh. So as we travel in this mesh, we cannot see any voltage source. So therefore, our constant is 0. So 0 is equal to, okay, so all resistors connected to mesh number 2, we treat them as positive. So that is 3 plus 4 plus 2. So we have 3 plus 4 plus 2 I2. Okay? Minus mutual resistances. So you have here minus 4 I1 because it is connected at mesh number 1. And we have here minus 2 I4. Because 2 is also connected both at I2 and I4, or mesh 2 and mesh number 4. Okay? So simplifying this further, we have 0 is equal to negative 4 I1 plus 3 plus 4, 7 plus 2, you have 9 I2 minus 2 I4. So let us call that equation number 2. Okay? So how about equation number 3? So let us go to mesh number 3. So where is mesh number 3? Here. Okay? So as we travel our mesh, we have here minus. Okay? So we will be leaving your source at the negative 2 volts. So we write here minus 2 is equal to, okay, all resistances connected or flowing or connected across your mesh number 3, we treat them as positive. So what are those? You have 1 and 3. So we have here 1 plus 3 is equal or multiplied by I3. Okay? And then we only have one mutual resistance here. That is your I1, which is connected at mesh number 1 also. So we will treat that as negative. So minus I1. Minus I1. Okay? So simplifying this equation, we have minus 2 is equal to minus I1 plus 4 I3. So we call this equation number 3. Okay? And then finally, we go to mesh number 4. So where is mesh number 4? We have here mesh 4. Mesh number 4. Okay, so by moving along mesh number 4, we exit your positive 2 volts. So therefore, we have here 2 is equal to, okay, all resistors connected to mesh number 4. So we have here 2 plus 4 plus 1. And that is I4. Okay? Minus, we have your 2 ohms resistor here, which is also connected across your second mesh. So you have here minus 2 I2. Okay? So simplifying mesh number 4, or for our fourth equation, that will give us 2 is equal to minus 2 I2 minus 2 I2 plus 7 I4. I4. So this is your fourth equation. Okay? So this is your first equation. See? All resistors connected to I1 are positive, and other resistors that are connected to 2 other meshes, particularly 2 and third and the second mesh, we treat them as negative. So this is our first equation. The same is true with our second equations. All of the resistors connected in I2, we treat them as positive. So that is positive 9. And all mutual resistances, so that is the one which is connected also to the mesh number 1 and mesh number 4, we treat them as negative. Okay? So this is 0 because there is no voltage source along that specific mesh. So for mesh number 3, all resistors along mesh number 3, we treat them as positive, like here, our 4 here. And then, the resistor that is also connected at mesh number 1, we treat that as negative here. So we have minus I1. Okay, so why negative 2? Because if we follow the mesh here, we will be exiting at the negative 2 volts here. And then lastly, we have mesh number 4. All resistors connected at mesh number 4, we treat them as positive. So this is 7. And mutual resistor connected both at mesh number 2 and mesh number 4, we treat that as negative. So why positive 2 volts? Excuse me. Because if we follow this mesh, we will be living at positive 2 volts. So therefore, this is positive 2. So we have 4 unknowns, your I1, I2, and I3. So no problem because we have 4 equations. Okay, so now what I want you to do is to solve for those 4 different currents using these 4 different equations. Okay, so I will leave that to you so that you can practice. Okay, so practice solving these simultaneous equations. Okay, we have here another equation, okay, or another type of circuit. So in this type of circuits, we have 3 meshes, okay? So we have mesh number 1, mesh number 2, and mesh number 3, okay? So we need to solve for I1, I2, and I3. Therefore, we need to have 3 equations, okay? So how are you going to write those 3 mesh equations? Okay, so just the same as what we did from our previous example. So let us write, okay, the 3 mesh equations. So let us start with mesh 1. So look at your mesh number 1, okay? So how many voltage sources that mesh number 1 will pass through? Okay, so following the loop here, following the mesh here, we have positive 20, okay? So we have positive 20 and we have positive 10. So both positive, so therefore they're additive. So 20 plus 10, we have here 30 as our constant. Okay? So all resistors connected to mesh number 1, we treat them as positive. So what are those resistors? We have 10 and 4. Okay? So we have 14 I1. Okay? And then all the mutual resistances will be treated as negative. So we have here 4. 4 is also connected at mesh number 2. So therefore, we have here minus 4 I2. Okay? And 10 here is also connected along mesh number 3. So we will treat that as negative. So that is minus 10 I3. Okay? So this is now our first equation. Okay? So let us now solve for our second equation. So where is that? That is mesh number 2. Okay? So here. So let us now look at the mesh. So let us follow the mesh. We have here minus 10 minus 10 and you have minus 8. Okay, so negative 10 and negative 8 both same polarity, same direction. So this is additive, but we have a negative answer. So we have your negative 18. Okay? So all the resistors connected at mesh number 2, we treat them as positive. So what are those? You have 11. Okay? So we have 11, you have 4, and you have 3. So we have here 15 plus 3, we have 18. Is that correct? 11 plus 4, 15. Plus 3, we have 18. Okay, so we have 15 plus, so we have 18 I2, and then minus. Okay, so what are the mutual resistances? You have 4 I1 minus, you have 11 I3. Okay, so we can rearrange this. We can have 18 negative is equal to minus 4 I1 plus 18 I2 minus 11 I3. So this is our second equation. Okay? And then finally, your third equation, we go to mesh number 3. So let us go to mesh number 3. Okay? So what is mesh number 3? So mesh number 3, let us follow the mesh. Okay, so we have here, it will live at positive 12. And positive 12 and positive 8. So both positive, so it's additive. So 12 plus 8, we have here 20. Okay, so all resistors connected at mesh number 3. So those are resistors 9 ohms, 10 ohms, and 11 ohms. So that will give you 30. Okay, so we have 30 I3 minus mutual resistances. So have 10 I1 minus 11 I2. Okay, rearranging, we have 20 is equal to negative 10 I1 minus 11 I2 Okay, so we have 11 I2 plus 30 I3. Okay, so this is our third equation. Okay, so first equation, second equation, and third equation. So what is important here is you have formulated already the three equations. So it is now easier for you to solve for this I1, I2, I3 using these three equations that we have formulated. So it is very simple to create your mesh equation. Okay, so knowing now your three equations, it is now your task to solve for I1, I2, and I3. Okay, so by knowing them, you can now solve for the current flowing across each of the different resistors here. So the important part here, class, is you know how to create your mesh equations, because once your mesh equations are correct, the probability of getting a correct answer is very, very high. But if only one equation here is wrong, therefore, it is very impossible for you to get the correct answer. So the first thing that I will be checking here are your equations. Okay, because if your equations are wrong, I will no longer continue checking your paper because automatically your answers are already considered as wrong. Okay, so we go to our last equation or last circuit. So this circuit has a current source. Okay, so this circuit has a current source between two meshes. Okay, so let us assign our meshes here. So let us call this your mesh number 1. We call this as your I1. Okay, we assign here your mesh number 2. We call this as your I2. And finally, our mesh number 3, we call this as your I3. Okay, so let us now formulate our 3 mesh equations. So we have 3 mesh currents, therefore we will be having 3 mesh equations. So for mesh number 1, no problem. This is not yet a super node, a super mesh rather. Okay, so we have here your mesh 1. So mesh number 1, we have here positive Vs is equal to all of the resistors connected at mesh number 1. So we have here R1 plus R3 multiplied by I1. Okay, minus. We have here the current, okay, or the resistors which shares resistor with mesh number 2. So that is R1, I2, then again minus. We have here R3 times I3. So this is your first mesh equation. Okay? So since we have a super mesh between mesh number 2 and mesh number 3, okay? So between this one, so this is our mesh number 1, this is our mesh number 2, and this is mesh number 3. So between mesh number 2 and 3, we have here your current source. So instead of KVL now, we have a KCL. Okay, so again, why do we have a KCL? Because we have a current source between meshes 2 and 3. So therefore, your mesh 1 is in the form of a KVL. Okay, our next equation is in a form of a KCL. Again, only we have KCL only if we have mesh, if we have a super mesh. Okay, so as you can see, which current I2 between I2 and I3 follows the direction of IS. So as you can see, your I3 flows in this manner and your I2 flows in this manner. So it has the same direction as I3 but opposite in direction as I2. So therefore, our KCL will be IS is equal to I3 minus I2. And let us call that our second equation. Okay? And our third equation, okay, is also a KVL. So how do we do our KVL? We will be removing the branch. Okay? So we will remove this entire branch. And then we will be having a bigger mesh. Okay? Without without that branch. So this is our bigger mesh. So this is our bigger mesh. This is your super mesh. Okay? So for our super mesh, okay, so we will be removing the current source here, the branch having the current source. So for our super mesh, as you can see, we don't have any voltage sources. So that means our constant is 0. So we have here 0 is equal to, okay, we have there I2 is flowing both at R1 and R2. Okay, so therefore, we have R1 plus R2 multiplied by I2. Okay, so we will be treating both I2 and I3 as positive because they are inside the super mesh. So we have here positive. Both R3 and R4 is included in mesh number 3 or across I3. So we have here R1, R3 plus R4 times I3. Okay, but as you can see, both R1 and R3 shares your mesh number 1. So this is minus R1 plus R3 times I1. Okay? So to rewrite our super mesh here, this will become 0 is equal to minus R1 plus R3 times I1 plus, we have here R1 plus R2 times I2 plus R3 plus R4 times I3. So this is our super mesh for 3 equations. Okay? So unlike the other examples that we have, if you have a super mesh, instead of having 3 KVLs, okay, you will be having one normal in this case, we have one mesh, our mesh number 1, and then we have one KCL between 2 meshes, okay, between wherein your current source is located, between 2 meshes, and then finally we have a super mesh. So super mesh is also a mesh equation, but we are going to remove the branch where the current source is located. So therefore, instead of having 3 KVLs, when you have a super mesh, you will only have mesh number 1 or 2 meshes, okay, and 2 KVLs and 1 KCL. Okay? So once you have already defined these 3 equations here, you are now ready to solve for the values of your I1, I2, and I3, your mesh currents. And then finally, by substituting those values, you can solve for the branch currents. Okay? So you can solve for the currents flowing across your R1 and R2 and R3 and R4. Just follow the directions of the mesh currents flowing across them. Okay? So that will be it. Okay, so practice solving simultaneous equations. So I have already included, you may use the Cramer's rule, or you may use the solving of simultaneous equations by substitution or by elimination. So there are many ways of solving simultaneous equations. The important thing is you have to have the correct mesh equations. Okay, so thank you very much for listening and watching this video, and have a nice day. Okay, bye.